Good evening, everybody. Welcome back to another session. So we're discussing on the oceanography analytics. We have done all the data understanding EDA process. So yesterday we have discussed on the decision tree. So what is decision tree and what are the types? Today we will be discussing on the XLR, simple linear regressions. So before starting simple linear regressions, yeah, so this is our page. So we conduct courses on data science, ML, data engineering in clouds. So you can go through all these courses. We have domain analytics. In the domain, we have cybersecurity, finance, marketing, HR, and supply chains. And we have learning resources. So in the oceanography analytics, we will learn the simple linear regressions. So what is a simple linear regression actually? So simple linear regression is a regression model that estimates the relationship between independent variable and undependent variable. One dependent. So here, simple linear regression is the regression model. So that estimates the relationship between one independent variable and one dependent variable. So by using a straight line, and both the variables should be in quantitative. So today's agenda will be on regression analysis. Then we have linear models, collision analysis, equation of a straight line, then and simple linear regression, transformations, and variance. So we start with the regression analysis. So a regression analysis is a group of statistical process, so which is used in R programming language and Python, so which determines the relationship between data variables. So generally, regression analysis is used to determine the relation between the dependent and independent variables of the data sets. So there is always one response variable and one or more predictor variable. So here the regression analysis is widely used to fit the data accordingly, and further predicting the data for forecasting. It helps business and organizations to learn about the behavior of their product in the market using the dependent and response variable, and independent and predictor variables in this have the different types of regressions. Here we have three regression models. The first one is linear regression. Multiple regressions and logistic regressions. We'll discuss one by one. Before that, here we have a definition of regression analysis. So the regression is used to study the relationship between two variables. So we can use simple regressions if both the independent variables and the dependent and the independent variables are numerical. If the dependent variables is numerical, but the independent variables is categorical. So it will be the best use of the Avona. Here there are some use regressions. They are testing if IQ affects income. So IQ is the independent variable and income is the dependent variable. So testing if hours of work affects hours of the sleep. So a dependent variable in our sleep and the hours of work is independent variable. So testing if the numerical of cigarettes smoked affects the blood pressure. So number of the cigarettes smoked in the independent variable and the blood pressure in the independent variable. Here we have regression analysis graph. So it is important to perform a scatter plot because it helps us to see if the relationship is linear or not. So first, we have when the both independent variables and dependent and independent variables are variables, are numericals. So we can repeat the data in the form of a scatter plot. So in the second example, we have the relation between body fat and change of the heat failure is not linear, and hence it is not as sensible to use the linear regressions. So linear regression models is one of the widely used among the three regressions. So in the linear regression, the relationship is estimated between two variables. So one response variable and one predictor variable. So linear regression produces a straight line in the graph. Here, X indicates the predictor of the independent variable, and Y indicates the response or the dependent variable. And A and B are the coefficients. So here implementing our IM function, LM functions. So it is used to create a linear regression model. Then we have multiple regressions. So multiple regression is another type of the regression analysis. So the techniques that is an extension of the linear regressions, and the model as it is used for more than one predictor. So variable to use the create model, mathematically the formula will be a plus x1 into b1. As same with the logistic regressions. Logistic regression is another widely used regression analysis. And here the techniques and predicts the value with the range. Moreover, it is used for predicting the values for categorical data. For example, email is another spam or non-spam, winner or loss, or male or female, etc. So mathematically, it will be y is equal to 1 by 1 plus e power minus z. This was about the three regression models. Here we have a scatter diagram provided, or plots are provided in a graphical representation. Here we have two continuous variables. So we must be careful that collisions does not guarantee cautions. So here we have a linear model. So linear model describes a continuous response on a variables such as functions of a one or more predictor variable. They can help you to understand the and predict the behavior of a complex system. You can analyze an experiment, financial and biological data, and linear regression is a statistical method which is used So a linear model example is a vertical scenario. So that can be modeled using a linear equations or vice versa. An example could be each pizza cost of $10 and the delivery is for free. Fee is 5 rupees for $5. So the linear model would be y is equal to 10x plus 5, where y represents the total cost and the x represents the number of pizzas. So here is an example. And in the regression, the relation of y and x is modulated in the following form. So y is equal to a plus b into x plus e. So y is the dependent variable. For example, income, and x is the independent variable. So y is the independent, y is the dependent, x is the independent, a is the intercept, b is coefficient, and e is an error of the term for the each observations. So the errors e is normalized distributed. So this can be tested by plotting an histogram of a preferential of a regression and by checking that they are all have a bell shape. Then we have collision analysis. Before that, let's check in the mind map. Simplification data science. What happened? Okay. Might be some net loading. So here collision analysis. So collision analysis measures the degree of linear relationship between two variables. Here a range of collision coefficient -1 to +1, and the perfect positive collisions are +1, and perfect negative collisions are -1. So there is no linear collisions here. You can check in the graph and we have a formula here for that. By using this formula, you can calculate the collision analysis. So collision analysis, also known as the bivariant, is primarily concerned with finding out the whether a relationship exists between two variables and then determining the magnitude of an action of that relationship. Then we have an ordinary least square, OLS. So ordinary least square regression, OLS, is commonly a technique for estimating coefficients of the linear regression equations, so which describe the relationship between one or more independent variables and independent variables. So simple linear or multiple linear regressions are used. So how do you find out the least square? So in all the cases of the formulas for the OLS, estimate remains the same. We have formula beta is equal to xtx minus 1 xty. So the only difference is in how we interpret the results. So why it is called as OLS? I think why OLS is called as ordinary least square. So least square is in y of least square in y is an often called ordinary least square because it was the first ever statistical procedure to be developed in 1800. So it is equivalent to minimizing the L2 normal. So OLS estimator is efficient. So an estimator that is unbiased has the minimum variance is the best. So the OLS estimator is the best estimator because OLS estimator have the least variance among all linear and unbiased estimator. So why should we use OLS? So here in the data analysis, we use OLS for the estimating the unknown parameters in a linear regression model. So the goal is minimizing the difference between the collection observations in some attributed data sets. The response predicted by the linear approximations of the data. So here, this was about OLS. Then we have simple linear regression. So we will be talking on the main topic, simple linear regressions. So what is a simple linear regression? So it is a simple So the definition for the SLR, simple linear regression, is the regression model that estimates the relationship between one independent variable and one dependent excuse. So simple linear regression is a type of regression algorithm that models the relationship between independent variable and a single independent variable. The relation shows by a simple linear regression model is linear or a slope straight line. Hence, it is called a simple linear regression. The key point is similar linear regression is that the dependent variable must be continuous and real value. However, the independent variables can be measured on the continuous or the categorical variable. Simple linear regression algorithms have mainly two objectives: model the relationship between two variables and forecasting the new observations. For the model, the relationship between two variables, such as the relation between income and expenditure, experience and salary, etc. For the forecasting and new observations, such as weather forecasting and according to the temperature and revenue of a company, according to the investment in a year. So here R squared also known as the coefficient of determination. So which represents the percentage variation in the output explained by the input variables or percentages of a response variable variation. So that is explained by its relationship between one or more predictor variable. So we have higher than R2 and the better than model fits your data. We have some mathematical formulas, SSR, SSC, SST, which measures and explain variations and which measures the total variation in a Y. Here you can see the intervals. We have prediction and confidence interval first. There are types of confidence interval used for predictions in regressions and other linear models. So here prediction intervals represent a range that is single new observations like for a given specified settings of the predictors. So we have prediction interval also. So which represent a range that is a single new observation like to fall on the given excuse me which falls on the given specified settings of the predictors. Then we have confidence interval of a prediction, so which represent a range that is mean and response is likely to fall given specified settings of the predictors. So the prediction in the interval is always wider than the corresponding confidence in the interval because of the added uncertainty involved in the predicting a single response of a worse than mean response. Here we have some screenshot of confidence interval levels. Then we have simple linear regression. Excuse me. Then we have an error variables. So before that, we will move to the code. Let me restart the kernel. Yeah. So first here we will import the pandas and numpys. After importing that, one minute. Yeah. So after loading the dataset, we have the data 108, 2 and 108. Excuse me.
Then we have the data description. Here you can see. Then we remove. Then we import matplot. Straight line. Then we have color regions. Then we will import stat models. Simple linear regression. Then we have scatter plot here. Same with we have another regression model and for error calculations. Here you can see the RMSE is 32.760 here. Then we will test the data. It's the obvious here. Then the test RMSE is 35. For the train, RMSE is 32. For test, it is 35, and for train, it is 30. Then here for error values, we have for error values, we record some conditions. Whereas is the critical part of the regression model. There are 4 required involving and distributions of E must be satisfied here. The probability distribution of E is normal. The mean of E is 0. And the standard deviation of E is C for all the values of X. And the set of errors associated with the different values of Y are independent. So in the oceanography analytics, so at present, ocean science data mainly provide on the decision making supports, and we have mainly provided decision making supports in the field. So including the climate prediction, disaster assignments, assessment, and social economic development. So in the particular complete numerical predictions systems based on the high performance, cluster provides technical supports. Then we have the marine forecasting services has raised 50 kilometers of the grid forecasting and a new generation of grid forecasting. The product with a resolution of 10 kilometers is under development. So all kind of forecasting products have been applied to study and red tides, green tides monitoring. So you're seeing sea ice monitoring in the fissures and the water quality investigations. So in addition, there are many institutions provided industry solutions based on the oceans science data. So CINE is a company which can provide a maritime data in that thematic model. So actionably clear indicators and big ocean data is one of the first organizations to explore the potential of vessel tracking technology. So the focus on the providing client with the exact solutions, so which required through bespoke development of a core data management and the tracking software components. The support provided by the marine scientific data, the social economic, development is mainly reflected in the gradual transactions of digital ocean. So to transparent ocean to the smart ocean, at an early stages, all the countries in the world were actively engaged in the construction of a so-called digital ocean. Present ocean-related industries are actively promoting the applications of a big oceans and science data However, industrial applications of the transformations of big data are a new phenomenon, and there is much previous experiments on the base of this. Therefore, there are still many problems to solve in the applications of the ocean science. We have small data shifts, where small data becoming big data, and big data tolerance, application areas. We compare the surface oceans and deep ocean data are fragmented and constituted. So the small ocean science data, however, these are great significance, not only the theoretical study of the oceans, but also the resources explorations and climate analysis. Whereas the defense and the other industries at present, deep oceans and data are still at the stage of data accumulations. So it is necessary to focus on the development and employment of this newly acquired data. It is necessary to focus for the deep learning, so deep oceans. So the integrations of all kind of the data and information, such as that related to the environmental, technology and resources, also need to happen so that the goals of the full-time domain and ocean situations are awareness. Whole ocean network coverage and all around information services can be realized. So all through the oceans, science data has been level of big data in the terms of total volume, and current big data machine learning models are often purely data driven and diverse from the theory. Therefore, The athletic and reliability of big data models requires the existence of a small data. So in order to consequence between data models and the theoretical mechanism, mining algorithm is the model of construction technology can be optimized. So the traditional big data mining algorithms rely on the divide and conquer, the transformations and strategy. So this needs to be search a large and complex attribute space has caused serious problems for the data intensive computing. So at the same time, due to complex collisions and the noise within the data, so it is not uncommon to the find meaningless patterns. So in order to effectively improving the data, mining and scientific discovery in the content of marine science, excuse me, the traditional model building techniques focus on the analysis of big data and mining of the descriptive and spatial temporal independence. So which has certain limitations where describing ocean systems process that are special and temporally correlated. The ocean is a key component of the Earth system and accurate precious prediction of change in the oceans. At the Earth climate system is a key means of scientific response to the mitigations of a global climate change. So the current forecast and the prediction of an ocean and the Earth system's changes are developing towards the multi-circle layer at a high resolution combined with artificial intelligence and with supercomputers. So these increasing numbers are integrated oceans and the Earth system observation data. However, it will take long time to realize comparisons of big data in the oceans and the big ocean data in the era which follows the development rules of the big data in the other industries. So the government will lead the development in the early stages and large companies will participate in the middle. And finally, small and medium sized entrepreneurs will become the main force to explore the applications and services. Nowadays, on the data level, the research institute are the core of the data accumulation, but not the core of the data applications. How the data is combined operations of a company. In the business is a problem on the one hand. So the data provider need to be estimated convenient way for the data sharing and analysis and expressions. On the other hand, the data user need to have capacity of data applications, and the ocean data are useful for climate predictions and environmental detections. So the organic combination of data science and the oceans science should be steadily promoted and focus the theory of field of ocean science and technology innovations.